some of the aspects of our technology which will unlock the data streaming era and data streaming across the organization everywhere. But you all would know that it's not just about technology, it's also about how that technology is brought to bear in every enterprise. And there's a lot to do to truly unlock that potential. Now, one of the biggest limiting factors of the way data is used in most enterprises is actually the people. It's not just the people that have access, it's the fact that most of the most important data that's stored in streams or available in the enterprise is often only accessible to developers. Now, I love developers, I was a developer, I am a developer, but I recognize that there are actually only 20 million or so developers in the world. 20 million developers, and there are many times that data consumers in the enterprise. And so if the data is just available for use and leveraging by those developers, it can't ever reach its potential. So that's why we've implemented technology like Stream Designer. Now, Stream Designer, which you can see here on the right, is a completely no-code technology that enables a non-developer, a data consumer, to access all the streams that exist, understand what is in them, use them, filter them, evolve them, improve them, process them, and to produce your own new streams that go out the other side, and those streams can then be consumed by that person, but by other people inside the enterprise, not just other data consumers in the analytical estate, but even by developers to build new applications to deliver new business services as well. It's a true unification of the way data is used in the enterprise and democratizes data. And of course, if we're going to unlock the data for use by everybody everywhere, we need to do a couple of things. Firstly, the data needs to be governed, and you heard Chad talk extensively about governance and making certain that the data is reliable. But we also need to be able to deliver a cloud platform that meets the world's highest standards for security, governance, compliance, and reliability. And we have been working on that for a very long time. We have the industry-leading controls, monitoring, compliance certifications, and we're continuously reaching higher to offer the world's highest standards to our customers. This has actually been a journey that we've been on for a long time. Apache Kafka was invented about 12 years ago by Jay and the other founders of Confluent as part of LinkedIn, and Confluent has been around for 9 years. And over that time, streaming has gone mainstream. You don't have to explain to anybody what Kafka is anymore. You don't explain to people what streams are. Streams are effectively ubiquitous. In all of the largest businesses, in all of the most advanced startups all over the world, streaming is a thing. And they are all leveraging it to deliver brand new, incredible experiences. So our journey continues. And we have an opportunity to take a lot of that open source Kafka streaming market and to bring it into our cloud data platform, where we can offer a lower total cost of ownership and, as Jay mentioned, yet offer more features, more capabilities. It's a better product that costs less. That's our opportunity to convert more of the Kafka ecosystem into our cloud. But it's not just that. Even that is just the journey beginning. You've heard us talk a lot about streaming, putting data in motion, about it being a way to convert data from being static into flowing through your organization. But to truly achieve that, we have to deliver a complete data streaming platform. Not just streams, a data streaming platform. We have to be able to stream, connect, govern, process, and share. And that's the data streaming platform that we're building. And it's that unlocks the $60 billion plus market opportunity that I talked to you about earlier today. So with that, I believe we're going to break into a quick Q&A session. So welcome back up, Jay and Chad.
That's right. We're going to be doing a 15-minute Q&A section, focusing on products. So we got a mic here, and Fahim has a mic on the other side. Let's take a minute here, set things up on stage.
Good. Click once more.
Oh. Yeah.
Hey guys, over here, Brad Zelnick, Deutsche Bank. Thanks so much for today and for the presentations. Just a simple question. Can you dive in a little bit on the investments required to bring Flink up to the standard of where you are with your core products today, and just how you see the evolution? Like when we look back in 5 years, what will be the relative scale of Flink relative to the rest of the business? Thanks.
Yeah, do you want to take that, Chad?
Yeah, so one of the things I'm most proud of in my career, actually, I've actually never seen this anywhere else, is we were able to decide we were doing Flink. We bought Immerok, and we announced our first product in less than 6 months. And I've been just super proud of the ability for us to take a company of, 20, 30 people, merge that with a company of, equal size and get those teams to work together. We really were able to take something that was designed to be run more or less on machines, non-cloud native, and we actually have a multi-cloud offering. And I think it speaks to the innovations that we've made in Cora, that we were able to take this new set of people, new set of technology, and really deliver that within 5 months to make it profitable. So I'm very excited about what we can do. I think Flink brings one more piece to Confluent Cloud that we didn't have before, which is hosting third-party code. So a lot of our work is really around making sure that we can do that super securely and super scalably so that we can basically run and power any of the streaming applications that are out there.
And I would just add the 3 pillars of differentiation I talked about, being truly cloud native, like really building from the ground up to be a cloud service, being a complete platform and being everywhere. When we thought about it, that really applies very directly to Flink as well, right? There's an ability to really build a processing layer as a service. I mean, we've seen this with the cloud data warehouses, as Chad would know much better than me. And the ability to integrate this with Kafka, with our governance, really make it one product that all fits together, and then offer it to customers, multi-cloud across all the environments they run in. Very much the same kind of three pillars of value, and I think that's helpful for us, just both in terms of guiding our investments, and then also just kind of simplifying the message to customers. You don't want to have different modules with different value propositions. You want to have just a very simple description of why you're better, why you're the thing that they want. And so when we think about where are we investing, I think those three are a pretty good guide for us. Obviously, a lot of details of, hey, what does it mean to be cloud native? What is the integration into the rest of the platform, et cetera? But those are kind of the right buckets.
Sanjit Singh, Morgan Stanley. Jay, I wanted to revisit the topic around AI and this sort of next wave of wave 2 AI applications that are going to get built, and where you sort of see the logical flow. So as I sort of imagine it, we imagine a customer, a stakeholder, user asking a question in natural language, and we have to surface that response that could span both structured data as well as unstructured data. And I guess the question is like, what is Confluent's role in providing those answers? And what percentage of applications do you think are going to need to be real-time going forward? And is there any difference between the real-time requirement for this next generation app versus the stuff that we've built the past couple of years?
Yeah. So it's a great question. So there is certainly a difference from the kind of more traditional machine learning architectures and the newer AI architectures. And I would say that difference tends to be less about the model building, which to some extent is kind of done for you, or at least mostly done for you by the kind of foundation model builder. And so, our role is very much, the connectors that tap into the different applications, bring together data, kind of munge it into the right format, help it be indexed for surfacing in these applications. Some of those details, I think, are still being filled in around us, right? So will the model that you're integrating with be like an open source model that you kind of fine tune yourself, or is it going to be something that you consume as a service? I don't know. And to some extent, it doesn't change that architectural pattern or our role. Will you be indexing and storing data in more traditional systems or into some kind of vector database, or will there be other aspects of integration into LLMs that have yet to emerge? I actually don't know the distribution of that, but it doesn't really matter to the end state architecture. Like the key problem is the data that's needed for these models is locked up in this mess of old systems that was not meant to serve any kind of real-time, query requirements, especially broadcast out across a bunch of systems. And that's the kind of key problem that has to be solved to, really unlock those use cases. So that's kind of a very obvious application. I think there's other integrations beyond that, right? So Chad mentioned kind of the usage at TikTok, which is, not just bringing together data in real time, but actually training the model, for you based on responses as they come. That's much more sophisticated. I think that is, that kind of real-time learning probably is an end state for a lot of these things, but it's not the starting state for most companies. Most companies are just trying to figure out how to, combine some version of their data with some version of intelligence and get that into a usable product right now. So I think in these early iterations, we're going to see, a lot of that kind of integration problem for data, and we'll see a lot of, applying AI to an incoming stream to augment it or improve it or classify data in different ways. I think those are the use cases we're hearing from customers, and I think are likely this first wave. Beyond that, I think the world opens up a lot more. We're still talking about, language models, but there's a lot more that can be done on different data sets and applications in many other domains. And so that's where it gets harder and harder to predict where this could go. I mean, I think it'll be interesting, and I think there'll be a role for us in a lot of those areas. But that's where it gets beyond kind of what people are doing today with what the technology does today.
Hi, Dave. Buck Turson, KeyBank. Good to see you. So I'm sorry that kind of a riff on Sanjay's question, but you said that obviously more compute, more data is a feature of having to do real-time Gen AI. But also when you were talking about the fact that you need to interact at prompt time and at inference time.
Yeah.
So I'm wondering what kind of feedback you're getting already, whether it's from commercial software application developers who are trying to develop applications and want that kind of data integration at prompt time, or whether it's enterprises that are seeking to build their own applications. So what are you hearing back from customers so far in terms of their needs for real time in order to hit at prompt time?
Yeah. The motivation for real time, I think is pretty clear when you consider the concrete use cases, right? And so that would be the case whenever the data that would be the right answer to your question needs to be kind of up to date and accurate. The inclination people have is they think, well, what will happen is we will take these models and we'll train them on the enterprise data, and that will be the way we answer questions. And I think that that's probably not the most obvious direction for this to go. It could be, right? That was kind of the TikTok example Chad gave. The challenge is basically a fewfold, right? So one, that enterprise data is private. Two, it has to be up to the moment, not like a year old or even a month old or even a week old, right? Like when you're asking Expedia about your flight, you don't want to know the state of your flight like a week ago. You want to know like right now. And in fact, when people interact with a company, it's about something right now. And so I think the majority of use cases will have some aspect that needs to be in sync with what you've done with the company recently, what you just bought, your interaction on the web, your interaction in person. I think a lot of these kind of co-pilot type or agent type use cases will have some element of that needing to be in sync with the world. And when that's not the case, customers are just confused. They don't understand why they're getting something that's, out of sync, wrong, hallucinated, not right. And so I think, if you think about how this is working in practice, it's actually not that difficult to understand, right? You're kind of materializing a lot of data about the customer and what they're doing in their interactions and other things. And you're, effectively augmenting the prompt that you're sending out to the language model and saying, hey, it's not just where is my flight, right? It's where is this customer's flight, given all this information about the flights they were supposed to take and the status of those flights and alternative routes and blah, blah, blah. And that enables the kind of complete and rich and correct answer off of the up-to-date status of the world.
Jason here with William Blair. First, just a clarification on the $9 billion in the TAM in the database market. Can you talk about what you're addressing in the database market? And then secondly, can you talk about the differences between Flink and Spark ecosystems? Yeah. And I'm assuming that's where you're going to run up a little bit against Databricks. Can you talk about that relationship as well?
Yeah, so when we think about where we're kind of taking spend from, as you said, a portion of that is out of the database market. And that happens in a couple different ways. And so, one usage for databases is, hey, you're trying to do some data processing. You're effectively loading it into a database, running some processing, and shipping out the result. Often it's some kind of batch job that would happen, at the end of the day or periodically throughout the day. That's the kind of thing that's just inevitably going to real time, that's moving to streaming, right? For the things where there's a lot of pressure to make it faster, it'll happen sooner. For things where there's less pressure, it will happen over time as it becomes cheaper and more convenient to do it that way. But over time, I think, that this kind of batch processing is really kind of an odd artifact of mainframe computing that just doesn't really make sense with how the world works or what the needs of applications are. And so it's literally just been held back by aspects of technology that made that more convenient that are, entirely going away, right? So there's no inherent limitation of streaming that means it has to be more expensive or that it won't get the right result, or there's no inherent limitation on that says, oh, there's going to be this category of things that will always be batch forever. It's really just a question of, convenience, driving down cost, building the ecosystem, to be able to make that the most obvious route. And so I think, we'll see that conversion happen over time. And I think that there are a blend of other database use cases once you take that kind of obvious batch processing stuff that move beyond just kind of the processing and into some of the materialization and storage of data. I think we'll see some of those move as well. To your second point on what's the difference between Flink and Spark? Yeah, there's some overlap. Spark was kind of a batch computing framework that added some streaming capabilities. Flink was more directly targeted as a pure streaming framework that added batch processing capabilities. So there's some analogy between the two. When you look at the user base, I would say that where Flink has really grown and thrived has been these kind of application, run the business use cases, and where Spark has really grown and thrived has been the kind of data scientists and data science workloads. And obviously there is some boundary between those two countries. There can be some border dispute there, but by and large, we don't see the data warehouses or, data lakes or lake houses as competitors, and we certainly don't kind of battle deal by deal with them in any way. Right now there's a very kind of rich and exciting competition in that analytics world, but the use cases targeting streaming tend to come to us, and often data flows out of that streaming estate into all these things, into the data warehouse, into the lake house, into the new generative AI systems. There's a bunch in that area that we're helping to feed. And so, by and large, these are partnerships, and we've won Partner of the Year awards from Databricks, from Google around the analytics area for that reason, because it is primarily cooperative rather than competitive.
All right, thanks everyone. This is the end of our first product-focused FAQ. We'll have more time later in the program with the rest of the management team as well. So right now we'll take a short break.